Hi, my name is Dave Lannom with Monroe Training, and welcome to today's segment on basic electrical. Today, we're going to be talking about relays. So, remember, there's some prerequisites for this course. All right, this course requires basic understanding of the material we covered in basic electricity, basic schematics, as well as basic meter usage. So, what's our agenda for today? We'll start with okay, why are we talking about relays? From there, we'll talk about how a relay works. Remember, always keeping it simple. We're going to do some tests actually outside of a car on a training board, and then we're going to go out to a vehicle and we'll do some on the car testing. Then we'll do a quick summary. So, why relays? I mean, think about it this way there are a myriad of items that are relay controlled. When we start to understand relay controls, it allows for a fast, accurate diagnosis of a multitude of systems. And the more confidence you have in your diagnosis, the more customer confidence we have. And remember, confident customers refer more guests. So think about it. I mean, there's just a few of the relays you might find in a car. I mean, anywhere from seat controls, air conditioning modules, power distribution relays, alternators, starters, all of these relays in a car. But hang on a minute. What's a relay actually do? At the short version is a relay is going to use a small amount of current to control a larger current. The low current side we often refer to as the control circuit, and the larger current side is controlled. Sometimes they're referred to as the primary and the secondary, with the primary being the control circuit. I mean, here's an example. I mean, if we looked at the starter motor really needs a lot of current. And if I had to run wiring all the way up to the ignition switch, large enough to handle a starter motor, it would just use too much wire. So what are we doing at that point? We're going to use a very small amount of current with a control that through the relay to control that much larger current. So we've got switch battery positive. We've Let's go backwards here. So what are we going to do? We're going to use a very small amount of current to control that high current. So look at it this way. On one side, we'd have the control circuit, and that control circuit is all low current. What do we need to make that work? Well, we need switch battery power. Once we have switch battery power, we need a load, and obviously, we need a ground, just like everything we've been doing so far. All you need for electricity is source, a load, and a complete path. So what are we doing on the other side of that relay? The other side of that relay, what we'll call that is the control side. Now, at that point, we're doing is taking that relay, opening and closing the switch. To do that, we need battery positive power to a switch, from a switch to the starter, from the starter to the ground. So that's what it does at that particular point. We've got a starter. So if that's what it does, how does it work? If we're going to use a small amount of current to control that larger amount of current, I need to remove that extra slide. So how's it working? I mean, first of all, remember, there's relays all over the car. Some of them are square, some of them may be more rectangular, but all of them are doing the same thing. How's that relay work? Inside that relay, you'll see an electromagnet. When we look at it on the schematic, we're actually seeing that as a squiggly little line. So what happens? What we do, we apply battery positive power to the low current coil. And just like we did when we were doing third grade, we wrapped a piece of wire around a piece of metal, applied voltage, it became a magnet just the exact same way it did in junior high. What happens when I stop the current? When I stop the current at that particular point, the magnetic field collapses. It's just a piece of iron wrapped around with a piece of wire. So, what did it do on the inside? On the inside, what we did was we energized that coil, the just wrapped up piece of wire. And what happens when we applied voltage to it? When we applied voltage, that voltage at that particular point was opening and closing that switch. Take a close look at it. Take a close look at it. So that's how it works. So when we have on one side, we had a low current coil. What do we need? We needed battery positive power to the low current coil. Once we had the low current coil, we close the switch. When we close the switch, we light the bulb, we power up the fuel pump or anything that the relay is trying to control. So when I look at any of these schematics, what I have to do is I can't just look at the big picture. I've got to take this and break it down into much smaller pieces. So let's take a look at just half of the relay. When we look at half of the relay, what do we see? We see battery positive power. The battery positive power comes in from there, at that particular point. What do? We had a switch and we had a ground. As soon as we closed the switch, we lit the bulb, or in this particular case, we energized the coil and we closed the switch. On the other side of the circuit, what were we looking at? That was the controlled side. We had battery positive power coming into this horn relay. We ran battery positive power up over to the switch. As soon as we energized that low current coil that we hid for now, we closed the switch, we honked the horn, we turned on the light, we powered up the fuel pump. So at that particular point, how do we test it? The first thing we have to do and really understand is how it works. So let's take a look at all of the relays removed. So let's take a look at the relay actually removed from the car and see how that relay acts and do a couple measurements. Now that we've actually seen it outside of a car, let's talk about what it takes to do this actually in the car. Now, half the battle when it comes to doing diagnostic work and diagnostic testing is not the test itself. It's a preparation work that we really need to have going into it. We're going to be taking a look at a 2018 Nissan Altima that's got actually a code in the body control module for the IPDM, and that's an Intelligent Power Distribution Module. Big fancy term for a smart fuse block, but it basically says that the fuel pump relay is stuck off. Now, what's it tell me to do? It tells me to take a look at the DTC logic. So when we look at the logic, basically what it says is when I energize the fuel pump, it doesn't see voltage. What could cause that? Could be a bad harness, could be a bad connector, could be a bad fuel pump. Here's what happened. The store actually put a fuel pump into this vehicle because it had no fuel pressure and they could hear the relay clicking, but it didn't fix it. So now it's our turn to go to work. So what are we going to do? We're going to take a look at that very simple relay. Now, remember when we talked about schematics? When we talked about schematics, we talked about that dashed line. And what that dash line means is that fuel pump relay isn't actually a standalone relay. That relay is actually built into the power controller on this vehicle, which means we're going to have to be able to diagnose it. So, how are we going to do that? We're basically going to keep it simple. What do we need? We needed switched battery power going to the low current coil from the low current coil to ground. On the other side, we needed battery positive power through the fuse. We closed the switch to the fuel pump relay. We energized the relay. Now, before we start doing any testing, we really need to take a close look at that schematic. And as we do that, when we look at that schematic, what do, what do we see? We see very, very specifically that we're going to need to take a look at connector E18, terminal 7, E63, terminal 41. We're going to have to go over here to terminal F84, terminal 69, E18, terminal 15. Well, you might be thinking, well, where the hell are those? You might be thinking, where are those actually at? So, what we're going to do is we're going to do a little bit of legwork on the front end. And we went into the connector view on the Intelligent Power Distribution Module Engine Room, or IPDM. And we took a look at each one. We looked up the terminal numbers and we could see the connector number. Right there, we had connector number 18. And then it actually gave me the view of the connector, both from the harness side as well as the terminal side. And from there, we could take a look and confirm that we were in the right place by taking a look at the color coding on our left-hand side. I did the same thing when it came to connector number F.
Your headphone wire keeps hitting mic.
So we did the exact same thing when we looked at connector number F84. And when we looked at F84 again, we had a terminal view from both the harness side and the terminal side. And I've got my color codes to make sure I'm on the right wire. Well, we're getting closer. We know where the wires are, but hang on a minute, where are those connectors? So what we do, we went back into all data, we looked at the connector view, we found out, okay, there's F84, there's AE18. I know exactly where they are located on the fuse block. And now I'm actually able to go out and to begin to do some testing. But when we do the testing, remember, all we're going to do is keep it simple. We're going to just simply take a look and say, okay, do I have battery positive power and a ground to the low current coil? And do I have battery positive power through the switch, close the switch to the fuel pump? Don't let it get more complicated than that. So we're here at the car now. We've taken a look. We've got all the information we need. So let's do some testing. Now that we know that we've actually got a bad controller in this vehicle, just for the record, what we did is we went ahead and I took the liberty of looking up some TSBs on this vehicle. And what it told me was, okay, here's the code. It's a short to ground inside of the IPDM. And if one of the below fuses is open, put a fuse in it. If the fuse isn't open, replace the IPDM. So why did I do all this testing? I did all this testing to make absolutely sure you knew how to do the testing, but there's a big reminder right here. Had we started by looking up the trouble code, looking up in all data, any of the technical service bulletins relative to this vehicle, we would have had a very, very quick answer that if the fuse is good, replace the part. Well, I'm a strong advocate of making sure that you've tested everything. If you use all data to the best of your ability, it'll avoid you wasting a whole bunch of time. So, in summary, keep in mind, it's not that complicated. What do I need for a relay to work? I need a very small amount of current to control a much larger current. When I energize the coil, we close the switch. When we close the switch, we light the light. Hope this has been helpful for you. Thank you and have a great day. All right, that was the first pass that I had not actually recorded before.
So, and then I